Hey everybody, thanks so much for being here. Welcome to DynamicsCon. I'm really excited to be at this event and to be part of it and sharing my expertise with you today. My name is Andrew Lensak, and today I'm going to be talking to you about a topic that's near and dear to my heart. I've presented on this topic at lots of conferences and user groups and chapter meetings and client sites before, and it's something that I've gotten a chance to use as an end user and as a consultant, which is demand forecasting in Azure Machine Learning, Dynamics 365, and Power BI. So we're really looking at building an end-to-end solution across the Microsoft stack to meet your supply chain needs. Once again, my name is Andrew Lensak. I'm from Arbella Technologies, where I serve as Solution Delivery Manager of Manufacturing. I've been in the Dynamics space for about 12 years now, starting off as an end user all the way back in Exapta 3.0, and now have been in the consulting world for about 8 years. Today's agenda in this supercharged demo about demand forecasting is pretty progressive. We're going to start off with an introduction to the tools that you've always had in Dynamics, the tools that have come across in later versions, and the tools you have now available, as well as potentially what's to come. So that gets into the Dynamics progression across the different releases of Microsoft Dynamics when it was Exapta, then AX 2012, and now Dynamics 365. We'll walk through the traditional process flow of setting up demand forecasting, using demand forecasting to generate statistical forecasts in Dynamics 365, analyzing and editing those forecasts, and then authorizing them for use in your supply chain and master planning processes. We'll even walk through a little bit of the technical stuff, how to set up your Azure Machine Learning experiment to support demand forecasting. There's a couple different versions, starting with the free version that you can use to set up your experiment and get going right away with Dynamics 365. We'll also talk about the time series models. What forecasting algorithms are available in this tool set? A lot of industry standard forecasting packages have lots of different time series models you can use, whether they're Box-Jenkins models, traditional regression, or seasonal type models, and so on. And we'll talk about what's available out of the box in D365, as well as what you can build yourself through the Power Platform and other tools. Then we'll talk about Power BI, how myself and some of my customers have used Power BI to leverage that in the demand forecasting process, particularly when it comes to analysis and long-term strategies for demand forecasting in the supply chain. Then we're going to get hands-on in a demo in a live environment for D365. We'll walk through the process. We'll show you some of the highlights, pros and cons, and discuss what next steps you can do to get your demand forecast process running in the system. So first off, what is demand forecasting? How did it come across in the Dynamics workspace? It's something a lot of companies do across many different ERPs. And to be honest, it's still sort of an immature process when it comes to Dynamics. There was never a tool set in the Dynamics 365, in the Dynamics product line that allowed you to generate a forecast until the introduction of AX 2012 R3. Prior to that, you had the ability to generate forecasts outside of the system through whatever tools were available to you. Maybe that was an ISV. There's lots of solutions out there like RockySoft Demand Planner, which is now Planning Edge, Farsight Solutions, which is an ISV that offers a product even for Dynamics 365 and sits on top of the standard functionality, SlimStock, Forecast Pro, and many others that are just demand forecasting tools that weren't necessarily built for Dynamics, but can be used to do demand forecasting. So when I look at Dynamics and the history of demand forecasting in the Dynamics products, when we go back to even when it was Exapta, it's this natural progression. We started with small tools, and since then, lots more tools have come out. So I really like to put this slide in context. I normally do this webinar and I show things like Zelda back when it was 8-bit versus what it is now in Switch, which is something like 256 billion bits. Don't quote me on that. I'm not technical, but I read it somewhere. And when you look at things like superheroes in the Marvel comics, we started off with Batman way back in the Adam West days. These guys looked like they were in pajamas. They weren't intimidating, and it progressively got bigger and stronger and more technology. And then the Christian Bale Batman, it became darker. With Dynamics, we've started with master planning and applying forecasts, but you didn't have the ability to really do true analysis in the system. You didn't have the ability to generate those forecasts. using that historical data you already had in your ERP. Then in AX 2012 R3, we got a solution for that with demand forecasting. And now in D365, we have the most up-to-date tool with demand forecasting and even more time series models. So let's talk a little bit about that progression and what we've had in the previous two versions of Dynamics. So AX 2012, as I mentioned, introduced demand forecasting to Dynamics. It started with SQL Server Analysis Services as your data analysis tool. You were exporting historical data from AX 2012. That could be sales order transactions, production transactions, transfers, inventory transactions, and so on. Feed those to SQL Server Analysis Services to analyze in your demand forecasting cube. That then used the different models that were available to generate a forecast off of that historical data. The models that were available were things like a simple copy over historical demand, where if you don't need statistical forecasting and you just want to use last year's history as a baseline and then maybe making manual adjustments to that. You had autoregressive tree cross prediction, which was a Microsoft developed model for short-term forecasting. You also had ARIMA, which is a Box-Jenkins method that's in most industry standard packages. This is for smoothing long-term forecasting processes. And you had a mixed model. In D365, we've moved away from that. We now have Azure Machine Learning Services, a much more advanced analysis tool. It gives the ability to learn the more data we get. The more data, the more accurate these forecasts become, the more knowledge we get about the different models and train them to analyze trends and see trends that we might not see the first one or two times we run that forecast. To approve the forecast in D365, we authorize it right there in the D365 user interface. So it's a much more seamless experience. To the user, it really looks like they're using one technology the entire time, which is the D365 user interface in their web browser. Whereas in AX 2012, you were exporting data. You saw that in what looked like Excel. You had to then publish that into your SQL Server Analysis Cube and then import the data back into AX 2012 to feed it to your master plans. Here in D365, you're just navigating between different forms there in the user interface. It also has more models available. Things that you see in more traditional standard forecasting packages. ARIMA is still there and copy over historical demand is still there. But now we have things like exponential smoothing and seasonal trend decomposition, which are really useful, especially when it comes to forecasting and leveraging different points in your historical data differently. ARIMA is a really good forecast model, for example, but it really weighs everything the same, where if we're more seasonal or we have products where we want to weigh the more recent history heavier than we do the history that's further in the past, then we can do that with some of these newer models. You also have two combination models and then an all model. The all model is really useful. It calculates your forecast using every one of these measures and returns the measure with the lowest mean absolute percentage error. So it does a lot of the heavy lifting for you. The only caveat to that is really performance. It will take a lot longer to run using 5 measures, for example, than 1. The other thing you often hear is that you want to see the output of all those measures, not necessarily just the one that returned the lowest mean absolute percentage error. Also in D365, we've really made it easier on the user, or Microsoft has, by putting everything you need in the master planning module. In AX 2012, there was forms in various modules. You had the demand forecasting setup and inventory management, and then you had things like forecast models in inventory management rather than master planning. So demand forecasting, master planning, inventory management had forecast models and item allocation keys, and you really had to navigate across the system to find a lot of the forms and configurations you need. Now they're pretty centralized in the master planning module, and even now the new workspaces you have in D365. And then the last thing to compare these two versions is what you have for key performance indicators and graphs. That's really something most companies want to see out of their demand forecasting output, and there really wasn't anything supported in AX 2012. You could use the data in the Excel files that you had to create pivot charts and try to manage your own graphs, but there was nothing pre-built out of the box. In Dynamics 365, we now have a graph of historical demand and forecast against the current forecast and see that graphically. look at that against the new data that was generated from the forecasting algorithms. Once you have your system configured to set up the different parameters you have with demand forecasting, and we'll cover some of those in the next slide, you have the basic flow of transactions. You configure the system, you then predefine or select which historical data you want to use in your forecasting calculation. For example, maybe I want to generate a forecast for the 2021 budget, and I want to use the previous 2 years. To do that, I will select the previous 2 years as my historical time frame to gather data for. I will also select which transactions I want to include in the forecast. Am I forecasting finished goods where maybe only sales order demand is considered to generate my forecast for the next forecast period? Or am I forecasting raw materials, where I might need to look at all sources of demand and consumption, like scrap journals and transfers, sales orders, production line consumption, or Kanban consumption? Once I do set those parameters, which transaction to include, what historical data to include, and what my next forecast period is, maybe it's, like I said, the year 2021, and I'm going to forecast monthly, then I set those parameters, I run my forecast generation batch job in Dynamics 365. It'll use Azure Machine Learning, the experiment that was configured to generate the forecast based on historical demand. And it will feed that to a form called the adjusted demand forecast, which is where in Dynamics 365 you can see the statistical output. You can view those changes, you can edit your parameters to run the forecast again. You can change dimensions to aggregate or disaggregate your forecast at any decoupling point, and you can also make changes to the forecast and then publish them to your master plan. You have full visibility of what was changed when users do make manual changes, so you know what the system generated and what a user may have manipulated. Once you're happy with that forecast, as I mentioned, you can publish it to your master plan. That's done by an authorized forecast process in Dynamics 365. So from a functional user, that is the process they would see to do their forecast process on whatever forecast period they choose, which for a lot of companies is, for example, a monthly bucket. But prior to that, we need to get something set up. We have to have some setup in the system to trigger this. How do we get Azure Machine Learning? So we'll deploy a demand experiment as a web service from the Azure Machine Learning service. I will show you how to go to the Cortana Analytics Gallery, set up that experiment with the Classic Edition, which is your free version, and how you can get that connected to your Dynamics 365 environment so you can start generating forecasts. And what are some of the features that you have here with that forecast once you do get it set up? One is the ability to generate supply and demand forecasts using that historical data, including the ability to import data from other data sources. So something that you come across on every Dynamics implementation is, how do we get historical data into a system if we're not actually importing that historical data? And there are data entities that support the ability to import data into a staging table that the demand forecasting toolset can use. And that data can come from legacy systems, such as a previous Dynamics AX version, or it can come from Excel, or it can come from even a previous legacy system that you then manipulate the data into an appropriate template to import it to D365. You have the ability to authorize that forecast for use, or you can just use it as a guiding principle on what you may need to purchase, transfer, or produce in a given forecast period. You also have the ability to aggregate and disaggregate at various dimensions, which is really useful. So maybe we want to see our forecast broken up by the demand warehouse or the delivering warehouse. Maybe we want to see customer forecasts, but we don't actually want to forecast at the customer level. Maybe we always forecast at the item level, but we still want the ability to break out forecasts by customer and see that and see the impact of that, see the impact of the change at a grouping level if we change something at the item level, and vice versa. What if I want to change something at a group of items and see how that drills down and impacts each individual item? I can do that in the Dynamics 365 tool by enabling and disabling certain dimensions. We can also predict dependent and independent demand by using the ability to select which transactions are included. So for example, if I am forecasting finished goods, as I mentioned before, maybe I only want to look at sales orders, that independent demand. versus if I have an item that maybe can be sold as both a finished good and a kit. Dependent demand might be the production order that consumes that finished good when it needs to sell it as a kit. And you have the ability to select which of those transactions are included in your historical forecast. You also have the ability to select and configure parameters that control how that time series is predicted and is calculated. For example, how do we control seasonality or missing values? If I'm forecasting using the forecast bucket of the year 2020, and it just so happens that we had no sales in May of 2020, do I want to use that as my baseline for the year 2021? Or is that an outlier? Is that something that we don't expect? Was there a blip? Did COVID, for example, impact our sales? And next year, maybe we either do or don't expect to repeat those patterns. Not all demand forecasting systems will inherently know that. So this gives you the ability to apply some parameters, massage, and really affect how that data is looked at and how the output of the forecast comes back to you as a user. It also supports intercompany planning. You have the ability to generate forecasts across every legal entity in D365 and F&O and SCM. I can view a forecast across all those companies, and then I could just authorize maybe the forecast for my company. So it gives you the ability to centralize planning if you don't have planners at every legal entity, every site, or every warehouse, and perhaps collaborate with other users who might be planning for those same products. And lastly, it gives us the ability to apply outlier removal. If I'm, let's say, in retail or something, and I get a customer order that's a very large order, a lifetime order, and maybe I don't expect that to repeat. I don't want that history to skew my forecast for future periods. So I can use a query-based outlier removal form to say which forecasts, which demand, maybe it's a specific customer, a specific item, a specific set of orders or dates that I want to exclude. I can select that in an outlier removal query so that when I'm generating my forecast, that demand is left out of the historical calculation. So D365 F&O demand forecasting, we're starting to really get into it now. We've talked about some of the parameters that live behind it. We're going to really get into the technical stuff in the next slide about the Azure machine learning setup. And we're getting close to demo time when we get to put this all together and build an end-to-end solution for demand forecasting. Based on my experience, I've had the opportunity to test this functionality really since it came out. I remember I was implementing on a client prior to AX 2012 R3 even being released that had a very advanced demand forecasting tool they were using that they were trying to replace. So we were kind of working with Microsoft R&D even prior to this product being GA to see if it would be a fit for that client. And ever since then, I've been using this tool and implementing it with customers and watching it progress. And I've gotten to compare it to other tools I see out there in the ERP space or even ISVs and add-ons to Dynamics 365. Some of this list comes from Microsoft itself, and I've kind of added based on my experience with it. So what are the pros? What are the big advantages of this out-of-the-box demand forecasting toolset? Number one is it's fairly easy to configure. Most of partners out there and a lot of advanced customers, if you're familiar with configuring other modules in D365, this isn't any more complicated than that. It's a familiar user interface. It's right there out of the box. You don't have to worry about learning a different interface, learning a new tool, building an integration. It's fairly easy to set up, and it's very quick to set up. Easy to extend, mass customize. I would say yes and no. It's easy to extend. The functionality is there the way we do extensions in Dynamics 365. You have the ability to do that. The flexibility with Azure machine learning to build your own experiments, that is definitely there. You do need a thorough understanding of how the master planning engine works, how forecasting works, and looks at that demand though to do those customizations. So I wouldn't say, give it to your most junior developers. If you need to extend and mass customize the tool, make sure you have people who are familiar with those data sets in the ERP. It is a reuse of the Microsoft stack and Cortana Analytics. You're using tools that you're already implementing. You have Dynamics 365. You're probably already using or looking at Azure Machine Learning if you're interested in analytics and business intelligence. So it's a reuse of that kind of common product. For developers or for companies that have data scientists who are going to help you build out your demand forecasting tool sets and principles, the Cortana Analytics Suite uses R or Python programming and a drag and drop interface. So a lot of developers are already using those tools and familiar with those tools if you need to build off of the tool set that's already provided out of the box with the free Classic Edition. The other thing that's a huge bonus is the ROI. This only costs what used to be called the AX license for production planner. I'd actually have to double check to see if that license role has changed since the new licenses have come out. But essentially, if you're already using master planning in Dynamics 365 and you're already doing production scheduling, more than likely you already have the right roles. You don't have to purchase anything else. This is pretty much comes with your out-of-the-box D365 licenses if you're already using those processes and you just want to start using the demand forecasting generator. So you can start with the free tier, as I mentioned, and then there are other tiers that you can upgrade to, standard tier and pro tiers if you need to. And we can always talk about that, the benefits and pros and cons of that if you require perhaps better performance from a higher edition. And then also, as mentioned previously, you have the ability to migrate historical data not only from previous AX versions, but even legacy systems. So if you come from SAP or Oracle or Infor or another one of these ERPs, and you're now upgrading or transitioning to Dynamics 365, if you're able to provide that data in Excel using the same item numbers and units of measure that you're going to use in Dynamics 365, then you have the ability to bring that legacy data into the data entities and staging tables that the demand forecasting tool set will use. Now, what are the cons? What are the issues with it compared to other demand forecasting tools we have seen out there? One is it might not be considered best of breed. It was originally designed for manufacturing companies. There's a lot of things related to retail and distribution and wholesale professional services that typically might have more factors in their tools for demand forecasting that might not be available in this tool. And this is actually right off the white paper that Microsoft provides with the demand forecasting functionality. They're fairly limited with KPIs and forecast models. As you saw, there was ARIMA and seasonal trend decomposition and exponential smoothing and a few combination models, but that's not that many in terms of an overall demand forecasting tool. Many ISVs offer as many as 30, 40 algorithms that you can apply. And I don't want that to be too lost. We'll get to maybe why D365 does that. There are algorithm parameters that I like to call modifiers that address some of that, where you might not need a full different time series model to address your concerns. That is also where we get into the developers using R and Python programming to create additional models as well. Forecast comparison is fairly manual and lacking. There's not a great tool to run multiple forecasts, compare them against each other. We will talk about during the demo a process you can do to do that I've seen many clients implement to pretty good success. But there is no tools, there's no forms right there in D365 that say, show me the ARIMA model and compare it to exponential smoothing for the same time period and compare different lags and seasonalities. That functionality just is not there quite yet out of the box. There's also no financial value of generated forecast displaying. You're seeing quantities. Most of that may have to do with the different levels of pricing and control you can have in Dynamics 365. And those calculations really only coming from committed forecasts, not necessarily statistically generated forecasts. And there's no built-in tools for promotion, new product introduction, or obsolescence. Once again, it's another one of these areas where we've built in some great processes that customers can use for demand forecasting and an overall S&OP planning, but there is nothing out of the box that allows you to say connect one item to a previous item and use its history, since the new item will not have historical data to use for forecasting. All right, so the technical stuff. Deploy your own service by using Machine Learning Studio and the Finance and Operations Demand Forecasting Experiments. This link here will bring you into the Azure Machine Learning Experiments. It allows you to open the Classic Edition, It gives you step-by-step instructions about how to set up that experiment. Docs.microsoft.com has these instructions really well outlined, and I don't consider myself a technical person at all. I was able to get that up and running in less than 15 minutes and apply that to one of my environments. Once again, that's the free Classic Edition. It has the built-in models that we've discussed so far today and allows you to set that up and then apply those parameters to Dynamics 365 FNO and SEM. You're then defining those time horizons, item allocation keys, and parameters. Technical, that's more of just the setup or the configuration of the module. And then the historical data that's gathered from the Dynamics 365 transactional database. This has really come from the invent trans tables in your database. It's looking at those transactions and looking at those reference types that you defined in your parameters to decide what should be forecasted against. So let's go in a little more to the time series models in FNO. We've mentioned what they are, but if you're not familiar with some of these, I like to say let's not confuse them with forecast models. Forecast models have existed in Dynamics and Exapta for a really long time. That's what allows you to align a forecast with a plan. Time series models are statistical forecast models. These are algorithms, and these are the 6 algorithms, or 5 algorithms rather, and then the all option that you have available in Dynamics 365. First is ARIMA. This is the autoregressive integrated moving average. This was available in 2012 R3. It's available in almost every statistical forecasting or traditional forecasting tool I've ever seen, whether it was an ISV or part of an ERP system, standalone package, agnostic to ERP systems type product, whatever it may be. Box-Jenkins methods are ones you normally see, especially ARIMA. It makes time series stationary by differencing, so what you get a lot there is that linear equation. You see a lot of averaging out of forecasts over time, not really a lot of seasonality being applied. Then you have exponential smoothing. This is used to assign exponentially decreasing weights over time rather than weighing all history equally like ARIMA might. So you see some of the impacts based on when transactions occurred and how to weigh them if something is more recent or further in the past. You then have seasonal trend decomposition, breaking time series into those components. There's a few parameters also for this to say what types of seasonality trends are we looking at. You have 2 combination models using exponential smoothing and seasonal trend decomposition, and then exponential smoothing and ARIMA. And then the all method, which I mentioned earlier, which calculates using every method, takes a little bit longer, and produces or returns the result with the lowest mean absolute percentage error. I always tell customers that's the best place to start, and then really practicing and adjusting use cases is really the important place to go. So we just got a couple slides here. We're going to really break this one down in the demo, but these are the main forms you're going to see in Dynamics 365. Once your forecast is generated, your adjusted demand forecast shows here. This is where you'd be able to view that data, manipulate that data. You can see I have my demand forecast and parameters. I could edit and rerun the forecast. I could change my dimensions. Right now I'm seeing very granular forecasts by item, including warehouse. Maybe I want to see that at a higher group level, like the entire legal entity, or perhaps an item allocation key or product grouping. And then here is my historical demand and forecast graphically, my KPI for that measure as well. Where the tool then needs to go, or where we've started to see a lot of users go, because the out-of-the-box tool loses, as we said, some of the analysis and things like that, is Power BI. How can we use Power BI to help us bridge some of the gaps that we have in demand forecasting? Well, number one is, if you're not using the demand forecasting tool, you can build forecasts and forecast tools in Power BI. You can connect to D365 online, for example, and pull out tables into Dynamics. It might not be the best approach from a technical end, but you have the ability to do that. And with data lakes and some of the technical changes that are coming from the infrastructure, that might become even more efficient here in the near future. You also have the ability to build DAX models through Python code in Power BI. So once again, extracting data and really leveraging Power BI to do your demand forecasting. You can always bring those forecasts back into Dynamics at a later date. You can stand Power BI up against D365, Excel, CSVs, other legacy systems. Maybe if you're in the middle of a project where not everybody's going live at the same time, you have forecasts in D365, in SAP, in Excel, in a fourth system, you can bring those all into Power BI and start to compare that data and analyze that data. You can use Azure to create additional time series forecast models if you want to apply that to D365. And as I mentioned, even build more DAX models in Power BI. So now we're talking about Azure, we're talking about D365, and we're talking about Power BI. How can we use all of these Microsoft products to take advantage over meeting our supply chain? And now with that, let's get to the demo and actually go through setting up our Azure machine learning experiment and then walking through the demand forecasting process in D365. So once you need to set up your Azure machine learning experiment, you'll go into the Azure AI Cortana Analytics Gallery. And you can see here that it's asked me to open in Studio Classic. So we'll go ahead and do that, and that will bring me to log in to Azure with my Microsoft credentials. And here mine are already set up, so it's automatically logging me in, and it's asking me to essentially create my workspace to copy the standard free experiment from the gallery. And then I want to go ahead and run that. And I'm going to run that service, and I'll be able to gather the parameters, the API key, and some of the passwords that we need to set up demand forecasting. So for example, if I navigate here over to my D365 F&O SCM environment, we go to our master planning module, we have our demand forecasting set up. And in our demand forecasting parameters, before we can generate any forecast, and even really before we want to set up all of the Azure machine learning parameters, we need to set up an API key and an endpoint address. And those are going to come from the Azure machine learning experiment. That's where you're going to get that data. So I'll go back to my Azure machine learning experiment. I'll deploy my web service. You can see I have my API key, so I can copy that key and paste it right here in a Dynamics 365. And then I can also run a test here on the API help page, and that's how I'll get the web service endpoint address that I'll put here. Once those parameters are set up and you've deployed that web service and it's running, you can finish configuring the module. In demand forecast parameters, you would set up a demand forecast unit because you need to have one centralized unit. That's for the purpose of aggregation. If I had multiple parts, maybe some are in inches, some are in pounds, and I try to put those in a group together, it needs to make sense of those quantities. So I have to have a centralized demand forecast unit. Mine is each. If any of my units or any of my items are sold in other units of measure, I need to have a unit conversion to support that for demand forecasting. I then set up the historical transaction types that are going to be included in my forecast. You can see I have sales order, production line, and transaction selected. I've selected to use Azure Machine Learning rather than the simple copy over historical demand. And I started to set my forecast algorithm parameters. So on top of the forecast models, our time series models, right now you can see I'm using all. We have additional parameters, like a seasonality hint. What buckets do we want to look for trends? The default parameter is actually 12. It's looking for trends over a 12-month period, if that's our forecast bucket is months. Here, 12.3.1, I'm looking for 3 types of trends: yearly trends, quarterly trends, and monthly trends. I can also apply minimum and maximum values if I want to try to manipulate to make sure outliers are excluded. I can choose that forecasting model and make it something specific, or choose all. And lots of other parameters like a missing value substitution, forcing seasonality, and so on. My forecast dimensions will allow me to choose what level I forecast out. I'm just going to choose item number and dimensions. And then I have the ability to group like items together. Item allocation key is a mandatory field. Items must belong to an item allocation key to be forecasted. And the purpose is to forecast items with similar trends, similar history, similar patterns together. Finished goods, for example, that might have seasonality should be bucketed in one group. The other thing item allocation keys allow you to do is have different parameters per item grouping. So I could have copy over historical demand on a set of simple items that really don't have much fluctuation year to year. And then I could have forecast algorithm parameters with Azure Machine Learning on my more complicated products. Once it's all set up, we're going to generate our statistical baseline forecast. This is where you're going to decide your historical horizon, the start date of your new forecast. You can apply additional filters to only include specific planning groups, item allocation queues, legal entities, or filter out specific data sets. And then you have the ability to say, what is my forecast bucket? Is it days, weeks, or months? How far out am I forecasting? And do I have a freeze time fence? Are there buckets in my newly generated forecast that I don't want to give the ability for someone to edit? That's what a freeze time fence will do. So here I'm saying I'm going to forecast out a year, 12 months. Each forecast bucket's going to be a month. The first month will be frozen. It's going to start on 8/1/2020 using the data set of 2015 to 2017. Now I have quite a large data set, so I've gone ahead and run this in advance. And it then appears in my adjusted demand forecast. So my adjusted demand forecast has returned based on the item dimensions, forecast dimensions I have set, the forecast that's generated. As you can see here, this first month is grayed out, and that's because it's my freeze time fence. I can't edit any of those values if I try. Whereas if I go one cell over into the non-grayed out cell, I can actually manipulate that cell, and it's now bolded it, telling me that I've manipulated that forecast. And if I go to check my demand forecast lines, I can see the original quantity that was generated by the system and what the new quantity that was manipulated by the user is. The other thing I may want to do is right now, once again, I'm looking at very granular information. I'm showing the item number, I'm showing the site. Maybe I want to aggregate the forecast and see just the total quantity across a specific item or grouping. I can come up to the top here and I can change my forecast dimensions on the fly. So I'm going to actually remove the product dimensions because I have this one item here that's actually in different variants, and maybe I just want to see the total forecast across all variants. I can do that. I can even remove item number if I want to see grouping at the allocation key level. Now I'm going to go ahead and run OK, and it's going to summarize and aggregate that information to the item allocation key, and I'll see those summary levels. So now I'm just seeing legal entity, site, and item number, for example, since I removed item allocation key. So a little bit different than what I mentioned there. I accidentally changed the wrong dimension, turning off the grouping level rather than the item level. But I could make the same change, turn off the item and turn on the group, and any manual manipulation that occurs will aggregate up or disaggregate down. So if I wasn't displaying item number and I made a change on the total item allocation key, that would push those figures back down to the individual SKUs. Also, at any point, I can check the forecast line details because this is really just the output of the forecast generation, and I want to know how it came up with those figures. Now I can see here was my historical demand based on the time frame I chose. So this is actually the transactions that occurred in the year 2015. If there was a forecast at that time, what that forecast was, which gives you the ability to show the previous forecast history and percentage error as well. And you can see that throughout the whole time horizon you've seen. So now that we get to 2016, I did have some forecasts in 2016 as well, and we can compare those to the actual historical demand and see what the error percentage was at those times. And as I scroll down further, I now have my new forecast, including manual adjustments. I can change the horizon if I want to see more or less information. I can see which forecasting model it chose, because remember, I chose all, so I wasn't going to know which products would use which forecasting model. And this one shows that it used exponential smoothing because it returned a MAPE of 40.23, which would have been the lowest of all the models it ran a calculation with. And then finally, I have my historical demand and forecast graphically. This one being a little bit odd, one, because I didn't have forecasts until 2016, and two, because my new forecast is in 2020, and because I'm in a demo data system, I don't have anything going on in those years in between. But I think you guys get a pretty good picture of what that may look like. Now, once we've analyzed all that data and manipulated it, that's when we may want to apply some of these forecasts to master planning, and we would authorize the adjusted demand forecast for use. When you select that parameter, you have the ability to redefine what you're importing. You may have generated out a forecast for a year and only want to import the next 3 months or 6 months. You might have generated forecasts for every legal entity and only want to import the forecast for the US company. You can do that as well. And you can also choose which forecast model that will be imported to. Once that is authorized, this last bit I'll show you here in the demo, the forecasts are pushed into the traditional table that you would have always used in Dynamics, which is here under manual forecast entry, demand forecast lines. Any authorized forecast will be dropped into this table. It's the same table you can manually create forecasts in. It's the same table we've always imported forecasts in if we were using ISVs or add-ons or homegrown tools through Excel. And this itself also has the Open in Excel feature with Dynamics 365, where you could actually expose the whole demand forecast entries table, manipulate, add, and delete data from there as well. And this model right here is what decides if it ties to your master plans or your forecast plans and is considered in master planning. So the last piece we do with customers is that analysis, that what's missing, that Power BI type experiment that we do. And we use this demand forecast entries form a lot for that. Because we have different models, what we do with a lot of customers is we have the D365 generated model through statistical forecasting, customer provided models, sales provided models, and so on. And those are all then used, exported from the system. Maybe we're archiving those on a regular basis, and then we're using Power BI to do the analysis and compare them to prove which of these forecasts is truly valuable, is truly reliable, is truly accurate. That way, when the next forecast period comes, we know which of those forecasts we actually should tie to our master plan and use in our S&OP processing. And then you can start to produce some graphs like this. I have some examples kind of pre-built for you based on my data. These are some really, really simple ones. You can get a lot more experimental and advanced with this. But here I have forecasts broken up by model. I can choose individual models and view them singularly, or I can view them all at once and see the differences between them. I have forecast plans. I also have a model for forecast accuracy. And then finally, some analysis. This breaks down the 3 different forecasts I've used for my data set, which is the D365 generated forecast, which we can look at, the customer provided forecast, which maybe I have customers who say we expect to buy this much in this next period, and then the current forecast, which is the forecast currently provided in D365. And you can see as I start to toggle these different parameters, that forecast structure looks a lot different. If I'm only looking at the current forecast, it's very flat and very stable. And then as I start to add in the customer provided forecast in D365, we see a lot of variation. So here we're just proving that the Microsoft stack, the whole tool set, D365, Power BI, Azure Machine Learning, there's lots of opportunity to build more end-to-end solutions and to solve some of these demand forecasting problems that really are hindering companies from doing their best work. So to quickly recap here, I'm just going to go back to my slide deck, ISVs. Number one, and we didn't focus this on too much today, but that process I went through, I couldn't have somebody simultaneously doing that same process and manipulating their own adjusted demand forecast. I'd really have to have finished mine. If I approve an adjusted demand forecast or manipulate one, I'm approving or manipulating the same forecast that that user is looking at. Number two is exception reporting. There's not a lot of good tools to say something based on history fell outside of the line of what we expect. There is mean absolute percentage error, but that's about it. And some other industry standard tools offer lots of different exception reports. Maybe those are waterfall reports. Maybe they're more graphical features. Maybe there's an automated way to archive files to bring things out and do better period reporting. One of the things that you saw is I could authorize a forecast and say which forecast model I'm applying it to. Well, if we reapprove or reforecast monthly, and last month I forecasted and it had an August forecast, September, October, and so on, and then next month I forecast and that's going to include an October forecast, I'm going to override what I forecasted last month. So I lose some of that history, and some of that archiving and the ability to keep some of that history for analysis purposes is really important. Maybe it's Power BI, maybe a solution path with reference to more DAX measures for accuracy and further analysis is a good approach to take. The item introduction and obsolescence process I've mentioned, you can kind of build that in yourself. You can use things like period allocation categories or try to manipulate some of the data. You can use some of the external data entities to support bringing in data, mirroring what maybe was new item introduction, but there aren't really pre-built tools for that, which a lot of other tool sets out there have. Alternative item number is something a lot of companies use in Dynamics 365 to solve that problem for sales orders, but that functionality doesn't actually link to demand forecasting. It would be really cool as an end-to-end solution to bridge some of that functionality together. Advanced or additional financial and budgetary integration, more flexible forecasting, groupings at the customer and item levels, and using some of these great new tools that we have in Power Platform and Dynamics to leverage more functionality is where I can see this tool really going and being a best-of-breed package, since it's not quite there yet. And then to recap, I just kind of put everything here in bullets for you guys about everything we've looked at today. AX 2012 and SQL analysis services, Dynamics 365 with Azure Machine Learning, using Power BI, the different models available, the different parameters available, the pros and cons, and hopefully some information that you can take back to your company to see if you can leverage demand forecasting with Dynamics and your S&OP processes. My contact information is here. You guys can look me up on social media, whether it's Twitter, reach out to me by email, reach out to me on my website. I started a podcast at one point last year, and this year kind of threw that off the tracks. Maybe I'll get that back on track for you all as well. I've really appreciated you guys giving me the opportunity to talk to you here at DynamicsCon. We have a whole great set of presenters. Thank you to everybody who put on this conference. I think there'll be a lot of great content for the next 2 days, and it's free, which you can't get any better than that. So thank you, everybody. And join me right now as we get into a Q&A.